In chemical engineering thermodynamics, understanding the energy changes during chemical reaction is essential, especially the enthalpy change. These values help engineers design safe and efficient industrial processes. In our experiment, we focus on a neutralization reaction between hydrochloric acid HCl and sodium hydroxide NaOH using a coffee cup calorimeter. This setup is simple and low-cost way to measure the heat changes at constant pressure. When HCl and NaOH react, they release heat. It's an exothermic process. By measuring the temperature change of the solution and using the formula Q is equal to mc delta T, we calculate the heat evolved. Then, by relating it to the moles of the water formed, we find the molar enthalpy and change of neutralization. This hand-on experiment not only helped us to apply thermodynamic formulas, but also give us insight to the real-world energy changes during chemical processes.
Along the thermodynamic, safety is a top priority, especially when working with chemicals like HCl and NaOH. Both are highly corrosive and contact with skin or eyes can cause serious injury. That's why in this experiment, we also study the material safety data sheet to understand the risk and handling procedure and emergency steps. Understanding whether a reaction is exothermic or endothermic is not just for calculation. It helps us predict potential hazards. For example, exothermic reactions like this one release heat to helium, which can cause flashing or thermal burns if handled carelessly. By combining safety awareness with thermodynamic understanding, we learn how to design and conduct experiments that are both accurate and safe, an essential skill for any chemical engineer.
Welcome to this enthalpy change experiment using a coffee cup calorimeter. You'll need a double-walled paper cup for insulation, a thermometer with 0.1 degrees Celsius precision, two 10 milliliters graduated cylinders, one for acid, one for base, 1.0 m hydrochloric acid, 1.0 m sodium hydroxide, and a cap with a pre-drilled hole for the thermometer. Safety first, wear gloves and goggles. Using your first graduated cylinder, measure 10 milliliters of 1.0 m HCl. Pour it into the insulated paper cup. Seal the cup with the cap to prevent heat loss. Insert the thermometer through the cap's hole. Ensure the bulb is submerged but not touching the cup walls. Wait 3 minutes for thermal equilibrium. Record this initial temperature as T. Now take the second clean graduated cylinder and measure 10 milliliters of 1.0 m NaOH. Quickly lift the cap, pour in the NaOH and immediately reseal. Gently swirl the cup. No stirring rod needed, the cup itself is your mixer. Watch the thermometer. As HCl and NaOH react, you'll see the mercury rise. When it peaks and stabilizes, about 60 seconds, record the final temperature T2.
Let's walk through the enthalpy change calculation step by step. We'll start by identifying the given data, then proceed with the necessary calculations to determine the enthalpy change for the reaction. Step 1. The information provided includes the specific heat capacity Cp is minus 57 kJ/mol. The temperature change delta T is 3 Kelvin. The mass of the hydrochloric acid solution is 0.0149 kilograms. The mass of the sodium hydroxide solution is 0.213 kilograms. Total mass is 0.2279 kilograms. Additionally, the number of moles N is calculated as 335.673 moles using the combined molar masses of 36.5 and 40. Step 2. Calculate the heat transfer. Using the formula Q equals mCp delta T. Substituting the values, Q equals 0.2279 asterisk, minus 57,000, asterisk 3. This gives Q as minus 38,970.9 joules. The negative sign indicates that the reaction is exothermic. Step 3. Determining enthalpy change. Enthalpy change is calculated as delta H equals Q or N. Substituting the values, delta H equals -38970.9 335.673. Simplifying delta H equals 116.097 joules, mol Kelvin. In summary, the enthalpy change for this reaction is 116.097 joule mol Kelvin. This calculation highlights the importance of accurately measuring mass, temperature, and moles to determine the energy changes in chemical reactions.